Okay, welcome back. Here's video 3. We're looking at the mass spring system. In our previous video, we did graph the amplitude versus time. We're going back and forth between 5 centimeters from the 0 mark to negative 5 centimeters from the 0 mark. Our job right now is to figure out the velocity versus time graph and the acceleration versus time graph. Let's do velocity versus time graph first. Okay, so let's look at what's happening. So when the spring mass system is here, it's going to be all elastic potential energy. When it's here, it'll be all kinetic energy. And again, we're assuming no friction. And when it's here again, it's all elastic potential energy. So it looks like our velocities are going to be 0 here. And at this position here, it would be 0. And that does correspond to our situation here. So everywhere we have maximum stretch, we're going to have velocity equal to 0. So let's go ahead and do that. I'm going to mark our time intervals on there just like we had before. I'll just mark them with dashed lines. We've got 1/4 of a wave, half of a wave, 3/4 of a wave, and then a whole wave. Okay, so let's go ahead and mark those. So when we're at 5, we're going to be velocity 0. Okay, when we're half of a wave, we're going to be velocity equals 0. And then one more time at this maximum here, we're going to be 0 again. So we'll be elastic potential energy converting to kinetic. So let's go ahead and do that to find the velocity then. So we know elastic potential energy is going to go into kinetic energy. So we're going to have 1/2 the spring constant, which is 25. And we'll multiply that by the stretch of our spring, which was 0.05 meters. And we'll have to square that. Equals 1/2 the mass, which is 0.250, times velocity squared. And when we solve for velocity, we get 0.5 meters per second. Okay, so then we can mark our max and mins for our velocity. This would be a 0.5 here, and this would be a negative 0.5. So anytime we're in these positions, okay, we will now be at the maximum velocity. But let's make sure we assign the proper direction. If we're here, our velocity is moving in this direction. So that would be negative starting off, wouldn't it? And when we're here going this way, it would be positive. Okay, so when we reach the 0 mark here, we'll have a maximum negative velocity. So I'll record that here. And then when we come here and come back this direction, we will now be moving in the positive direction. So I'll map that here. So anytime we're at the 0 position, that means the block is located here. Starting from here, we're at maximum kinetic energy, but our velocity vector is pointing left. And then we will go all the way to here, and then when we're coming back in this direction, our maximum kinetic energy, meaning maximum velocity, but we'll be traveling in a positive direction. And let's see if I can connect that wave nicely. And it looks like a normal sine wave. Now again, for you calc students out there, this is the cosine wave. The derivative of cosine is negative cosine, and that's what we're seeing here. Okay, now I'm going to superimpose on top of this. Let's look at the force of the spring now. We know the force of a spring equals kx. Okay, so here the spring is completely unstretched. So the force there would be 0. So I'm just going to remind us that there was 0 here. Here we have the force of the spring equaling kx. Okay, but that'll be pointing in this direction here, will it not? So we'll have a negative acceleration going this way. And at this position here, we'll have force of the spring equals kx, but that'll be going in this direction here. So that'll be a positive acceleration. So we'll have a maximum acceleration where the spring is stretched the most at this position. We'll have no acceleration here because the spring is not stretched. And then we'll have a maximum positive acceleration going on here. Okay, where the spring is completely compressed in the other direction. So one more time, let's go here. Again, we put in these 0 marks then, where our maximum velocity is, let's put our marks here. So this is 1/4 of a wave, half a wave, 3/4 of a wave, and then a full wave. So we know at this position here, we are going to have no acceleration. So I'll put the 0 there. Okay, and at this position here, we're going to have 0. Now, why does that work? Well, the net force on at any time is going to equal the force of the spring. So we always put in force net mass times acceleration. So I'm going to say 0.250 times A is going to equal 25 times, well, actually not, 25 times 0.05. Our spring constant multiplied by the stretch. So acceleration is going to come out as 5 meters per second squared. Okay, so that means 5 meters per second squared here, 5 meters per second squared here. But when we're here, it's going to be a -5 because we're accelerating this way. When we're at this position here, it'll be a +5 meters per second squared because we'll be accelerating in this opposite direction here. Okay, and that's how it's going to work. So we're going to look at these positions here again. When velocity is equal to 0, that means we're at our maximum stretch, which will be our maximum accelerations. Okay, our first time, we're at this location here. So we're going to start off at it, and we're going to put our values here. We'll have a +5 and -5 acceleration, so I'll just label that as 5. And this one is -5. So we're going to start off at -5 initially here, because we're located at this position here. When we get to here, see how our acceleration will go to 0 because our stretch will be 0. So force net is always equal to force spring. And then when we reach here, we'll have maximum compression of the spring, which means maximum acceleration back that way. So that'll be a 5. Okay, and then we'll reach here. We're back to the 0 mark. And one more time, we'll end here when our spring is back at this location here. So then we'll have an acceleration graph that looks something like this. And again, for you calc students out here, we're starting with a cosine graph. We're ending here a negative sine graph, and then a minus cosine graph. So amplitude versus time, we take the derivative to get the negative sign to get velocity. And then one more time, we take the derivative of this to get the acceleration. And that's how the spring mass system works.